This is Arm's Silicon Valley base in San Jose. Usually we'd have 1,000+ people in our US offices, part of a global workforce of 6,500 people, 80% of whom are engineers. But like all companies, the pandemic has affected how we work. Our people have coped well, but there's still a desire to get back to the office. So now we're planning what that will look like. We'll have new entry procedures as set out by county and state law, and beyond that, elements like track and trace.
I am good. I am approved for the day. Some of this.
The world's offices will be transformed by COVID. I think being away from places like this has taught us just how valuable shared physical space is. And as well as where the furniture goes, there's a huge role for technology. And that's led us to start a conversation with Johnson Controls. JCI has been developing automation and control equipment in buildings for more than a century. They're a major user of ARM-based chips, and now we're talking to them about the enhanced AI and security features coming with the new Armv9 architecture being launched today. JCI's OpenBlue platform is conceived around the potential use of advanced CPU, GPU, and specialized cores, like MPUs, to deliver specialized processing task by task. One upgrade JCI is considering is the use of AI-powered digital twins, monitoring key equipment in real time within the company firewall, as well as aggregating data in the cloud. But AI isn't just for tomorrow. JCI has already used it to manage chiller systems and cut energy use by more than 50%. I think the kind of conversation we're having with JCI will redefine the language of buildings, introducing terms from the tech sector's dictionary, such as confidential compute, distributed intelligence, and software-defined. And from California to Cambridge, our global headquarters is home to more than 3,000 of our people. It's been the main center of operations for the development of the V9 architecture. The work carried out here enables our 1,000+ partners in the world's largest technology ecosystem. It's our partners' innovation and domain expertise that turns Arm's technology into a vast array of end products, best-in-class compute based on specialized processing that's transforming everything from sensing to supercomputing. Technology will always have an infinite number of challenges to solve. A near-term one might be us needing to prove we've been vaccinated against COVID-19. We could use our smartphones for that now, maybe with a trusted digital certificate sitting on the device. But think beyond that. It might make sense for us to carry our medical data around with us in digital form, including things like allergy or medication data. So no matter where you are, critical information could be accessed quickly. But for me to get comfortable with something like that, I'd want advanced encryption running on my device, beyond what's possible today. And that's where our V9 architecture comes in, with features such as memory tagging to help eliminate memory safety issues, and a little later, realm management, providing a vault for secure data manipulation. Both of these elements are central to Arm's ongoing commitment to dealing with complex cybersecurity challenges.
Arm's new V9 CPU will no doubt play a key role with its improved security, performance, and power efficiency. Our first smartphone product with V9 CPU will be commercially available by the end of this year.
Alongside new security features, V9 provides a scalable vector extension upgrade, SVE2. This extends support for specialized AI, DSP, and XR workloads. AI gets a further boost too, with future graphics upgrades for matrix processing. We've been pushing hard on the AI ability of our processors for several years, and it's paved the way for a vast range of specialized applications. But AI remains hungry for ever more efficient compute power. Our partners want to realize their own individual AI futures, and it's up to us to take every opportunity to help them. It's exactly why we're excited about the future of Arm with NVIDIA. The combination of Arm's compute platform and ecosystem with NVIDIA's deep expertise in artificial intelligence will create the world's leading computing company for the age of AI. This combination will bolster our R&D capability and lead to new and exciting products that will propel Arm's vision. Specialized processing built on the economics, design freedom, and accessibility advantages of our ubiquitous computing platform, enabling our partners to deliver best-in-class solutions across all markets. Staying with big ideas, I'm confident that every bit of digitally shared data will soon be securely processed on Arm-based technology at some point in its life. either at the endpoint, in the digital networks, or the cloud. That simple truth ties our future to the future of computing. It also puts great responsibility on us. And as an engineer, as well as a CEO, I relish that. V9 advances our cause hugely, even though today is only the start of the rollout. It's the kind of moment that ordinarily we'd want to gather together with our colleagues to celebrate. And that's exactly what Rene Haas and I would love to have been doing. But for now, the champagne's staying on ice. It's coffee only. Hi Rene, so we've launched V9 and it's a significant step in our technology roadmap. But let's look forward a bit. How do you think that this architecture will accelerate the key sectors that we're addressing?
Hey Simon, gosh, V9, where to start? You know, this is a release really unlike anything else that we've done here at ARM. One of the things I think about with V9 is how it really embodies everything that we've been doing around total compute. CPU, GPU, NPU. We've seen examples in the marketplace already where we've seen some really significant performance gains. One of the examples has been the M55, U55, that combination. Almost 500x performance improvement over standard frameworks using machine learning. That's going to find its way into automotive, autonomous, and all kinds of examples. One of the things that really excites me about V9 is around what it's going to do for developers. You know, we talk about something like write fast, run fast. It needs to just work, and V9 is really going to be able to enable that. We're working with a lot of our partners. You know, one is with Microsoft around a common tool chain for IoT developers. That's going to be really cool. We're also working with Unity, performance by default, getting great performance for 3D and VR. But probably the single biggest thing around V9, I think, is with security. You know, we all remember what happened with Spectre and Meltdown a few years ago and all the havoc that that caused. There's a lot of things we're doing with V9 that are going to improve that. Things around trust, confidential compute, using realms, just a whole series of things that will make it really, really great for developers and users. V9 is going to be the foundation for the future. I really could not be more excited about the potential.
It's been an amazing, tragic, and enlightening year for all of us, no matter where we've been living or working. Now, it's time to rebuild a world that's inherently more resilient. In compute terms, one of the most urgent needs is expanding the data processing capacity in the cloud. But we can't just do that at any cost. Transforming the cloud isn't just about more, it's about different, especially when it comes to the performance per watt of traditionally power-hungry data center chips. AWS has been leading the charge here with its revolutionary ARM-based Graviton SoCs. There's plenty of data showing how cost and power efficient they are, but we have our own evidence. At ARM, we've been using Graviton for our design cloud for processor IP and verification. It's helping us cut our data center footprint in half and on-premise infrastructure by 80%. If that's not enough, we've already seen 6x better throughput for EDA flows, and there's potentially more to come. The kind of innovation from AWS is being replicated throughout the ARM ecosystem, old thinking giving way to new approaches. Like the drone being trialed by the South African National Blood Transfusion Service. It can move from vertical takeoff to conventional flight and travel up to 100 kilometers, delivering plasma to remote areas. The developers, Quantum Systems, are using ARM-based intelligence to run the complex compute that keeps the drone steady in all conditions. Elsewhere in Indonesia, it's the jungle that's at risk. Illegal loggers cutting down trees that today help the planet to breathe. The jungle is a vast area to protect. The solution is a simple but highly effective audio monitoring system built on ARM-based chips. It has transformed a troop of too few rangers into a precision task force, using data in real time to stop the illegal logging. Another huge challenge has been the fight to find COVID-19 vaccines that cope with viral mutations. The US-based Folding at Home project encourages people to offer up spare compute cycles, including those from mobile devices. Those cycles are used in a virtualized global supercomputer.
There's billions of computers out there, and the number is growing as more and more people have powerful smartphones. We're by no means limited to working on this small set of viral proteins, so we've got active projects on Alzheimer's disease and antibiotic resistance, improving the yields of crops. We're working on multiple forms of cancer and Ebola virus. So the breadth of this is really exciting.
Even I still marvel at how pervasive our technology has become. In a year's time, our partners will have shipped a cumulative total of 200 billion chips. Putting that in context, half of that number, the first 100 billion, took 26 years to reach market. If our prediction is correct, the second 100 billion chips will have shipped in just 5 years. Our objective is to allow the broadest set of developers to write fast, run fast on ARM. In an ecosystem as broad as ours, the range of collaborations is simply enormous. Take Project Cassini, which creates frameworks for building secure servers, 5G base stations, and other devices optimized for cloud-native software stacks. Cassini's objective is that everything just works, so chip designers and OEMs can ensure their products work in harmony with the entire spectrum of software applications and services. The Cloud Native Computing Foundation, CNCF, is another example, this time of the open source community where ARM plays a key role. Our support for open source software continues to grow, with Linaro taking the lead for ARM-based Linux. Beyond open source, broad support for developing on ARM is accelerating, with improved tooling across multiple domains. That ranges from native development with Microsoft Visual Studio to performance analysis in 3D gaming with Unity and well beyond. With so much development and so much specialized processing running on ARM, we're seeing our ecosystem expand on a near daily basis. ARM's vision is built around sparking the world's potential, creating a future designed by millions of minds. Elements of that future are still inside the heads of young people, learning about computers on boards like the ARM-based BBC Microbit, the successor to the BBC Micro that I started my coding career on many decades ago. We're focusing on the microscopic detail and the macro impacts that ARM-based technology is having today. I'm truly excited to see what the new Armv9 decade will deliver.